Hello and welcome to a nostalgic ramble with me. And today we are looking at a stats question, data handling, from IEB May 2024, paper 2. What did I want to say now? I forgot. Anyway, question 1B. Yes, I think that's what I wanted to say. This is question 1B. Right. The box and whisker plot below represents the times in seconds taken by a group of 60 students to run 200 meters. So let's just quickly familiarize ourselves with what's been presented. So the fastest time was 24. The median time was 31. So that means half the students ran faster than 31 seconds and half the students ran slower than 31 seconds. And the slowest time was 34 seconds. And so this is half the data right here, right, which is quite a short range for the slower half, right, from 31 seconds to 34 seconds. Half the people ran in this range. And then this range is quite spread out. So this is an example of negatively skewed data where you've got quite a spread out left half, and quite a concentrated right half. And what we'll see is in a data set like this is that the mean time, running time, how do you say that, will kind of lie in this half. It will be something less than 31 because this tail drags the mean down, right? Makes the mean lower. So pretty much the top runners are making the rest of the class look good. Makes the class, it uplifts the average of the class, But in reality, as you would expect, you've got 60 students, you would expect that a whole lot of them kind of run at slow, just the more normal pace. And then you've got your top half. And in fact, let's see, so this is a quarter of the data and this is another quarter of the data, which is quite spread out as well. This is also a little bit spread out. I would have thought that maybe here we would see closer, like a shorter tail. This is 15 students roundabout. But even within those top 15 students, you see that there is a spread of running times. So it's a situation where probably the top are really, really amazing, and then you start getting some divergence, some interesting diversity of runners over here, and then bottom half, we're just walking. Something like that. The range, so across the 60 runners is fastest time 24 seconds, slowest time 34 seconds, which actually isn't all that horrible, right? 10-second difference between the fastest and the slowest person. That doesn't feel horrible. But for 200 meters? Anyway, right. So, question 1. How many students ran between 27 seconds and 31 seconds? So, 27 seconds and 31 seconds. So, that is Q1. Between Q1 and Q2, how many students are there? So I'm just going to highlight that. So that is quartile 1, and that is the median. And that would be 15 students, right? Because 25% of the data is in the first quartile, and then the next quartile, the next quartile, the next quartile. Each quartile has 15 students. A quartile is just, a quarter of the data set. So that would be a quarter of 60, which is 15 students. Right. Then, using the formula Q1 minus 1,5 times the interquartile range, determine whether 24 seconds would be an outlier or not. So what is Q1? Q1 is 27, as we previously saw. And then the interquartile range would be Q3 minus Q1. So IQR is equal to Q3 minus Q1. Q3 is 33 and Q1 is 27, as we previously saw, and that is 6. So if we then work out Q1 minus 1.5 times IQR, that will be 27 minus 1.5 times 6, which is 27 minus 9, which is 18. So this would be, anything lower than 18 would be considered an outlier using this formula. And 24 is not lower than 18, so therefore 24 would not be an outlier, because 24 is not smaller than 18. Right. Awesome. Last question. The time for the fastest student was recorded incorrectly. It was 25 seconds. Oh no. So instead of the fastest student being here, they were actually here. How would this affect the median? It does not affect the median. Right? It does not affect the median because, remember, the median is the midpoint. Not the midpoint, but if your times were 25 and then 26 and then blah 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 blah, if they were ordered from smallest to biggest, somewhere in the middle you would have this 31, right? And then you would have 32, and blah 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 until we get to the last point, which is 34, right? And so whether this is 25 or 24 is immaterial. It doesn't move. You're just shuffling values in the bottom half. So that's not going to impact what we determine to be the middle. Whereas if, for example, we were to discover that the fastest student actually we just actually got it completely messed up. This person, the person writing down, their handwriting was just illegible. So actually their time was not 24, their time was 34. So now it would be a situation where this 24 has to be removed from the bottom half and moved to the upper half. So that now is actually shifting everyone's positions, right? It's not just playing around in the bottom half, but the middle is still the middle. I don't know, maybe it'll be easier for me to demonstrate with, if we had 1, 2, 3, 4, 5, right? If we were to discover that, so this is our median, right? If we were to discover that the 1 is actually a 2, it's fine, because all of these things are still lower than 3, so it doesn't actually even matter. Like, all the drama is happening in the bottom half. But if we were to discover that the 1 was actually meant to be a 10, now all of a sudden something that was in the bottom half is having to move into the top half. So the middle is no longer the middle, right? 3 all of a sudden is actually now part of the bottom half. And so our new median is actually now 4. So yeah, it's not It's not a great explanation. Looking forward to how the memo explains it, but I hope it makes sense what I'm saying. You know, yeah. Let's see. Let's see what the memo has to say. I rest my case. I rest myself. Oh, and they don't even ask you to explain the effect. I'm just here tying myself up, and you just had to say it does affect or it doesn't affect. It just says no effect. Wow. Anyway, first question, the answer is indeed 15 students. Next question, we determined that this value that we were asked to calculate is 18, and 24 is therefore not an outlier. Very important to state that, because that is what you were asked. You must read to comprehend. Right, and then the last question was, how will this affect the median? It has no effect on the median. Nice, clean, finished. And if it did have an effect on the median, so if it was a situation like this, then you would say that the median would become smaller, for example, and not try to twist yourself explaining why the median is becoming smaller. Hey, just answer what you're asked. Answer what you are asked before you incriminate yourself, kids. Anyway, okay, bye-bye.